All right, we're covering 9-3, which is transforming functions. This is going to be more an extension of the transformations that we've been doing all year. So we're going to transform functions, recognize transformations of functions. Here are the rules we've had all year. So horizontal translation, any kind of horizontal translation is within the function rule itself. So here's a horizontal translation. If x or h is greater than 0, it's right, less than 0, left, which means in the equation a plus means left and a minus means right. Vertical translation, you add outside the function equation or rule. Negative is down, positive is up. Reflection across the y-axis, horizontal translation. Replace x with negative x. Reflection across x-axis, which is vertical. You put a negative in front of the function equation. Horizontal stretch, so a stretch of b is you're going to replace x with 1 over b. So remember, this is the reciprocal of the actual function compression or stretch. And for vertical, you're going to multiply the function equation by a. So for piecewise functions, translations can change not just the function rules, but the intervals. So remember how we have f of x equals, and then we're going to have equation 1 with x maybe less than, and then equation 2 with x greater than or equal, and etc. So horizontal translations can change both this and this, so be careful. Vertical translations are only going to change the equation, so they will only change the function rules. So it's a little bit trickier with piecewise functions. All right, here's our first example. Here's a piecewise function. And it said write the rule for a vertical stretch of factor 3. So the good news is, since it's vertical, we don't have to make any changes to these. And we will multiply both of these equations or function rules by 3. And that's what happens here. Just distribute, and your final function rule looks like this with no changes to your intervals. And if you'd graphed it, you could see this is going to be kind of horizontally compressed but vertically stretched. The next example, I asked you to do it, but I thought I'd talk about it a little bit because it does involve a horizontal stretch by a factor of 2. So remember, it's going to be, you're going to replace x with 1 over b. So b here is 2. 1 over b is going to be 1/2. So here I replace x with 1/2 x. Here I replace x with 1/2 x. It doesn't change these because it's a multiplication factor, and this is 0. So since 1/2 times 0 is just 0, these end up not changing. So horizontal changes don't always change those rules, but they can, or the intervals, but they can. And you could simplify that potentially by saying 1/4 x squared, but you can leave it like this as well. We're going to talk about how transformations affect the intercepts of functions, and we haven't done that before, I don't believe. So horizontal stretch or compression, and it makes sense if you're going to do something horizontally. The x-intercepts are multiplied by b, but the y-intercepts don't change. So since it's no vertical change to it, it makes sense the y-intercepts aren't going to change. A vertical stretch or compression doesn't change the x-intercepts, but the y-intercepts get multiplied by a. And I think if you think about it, that kind of logically makes sense. Reflections. So a reflection across the x-axis is a horizontal, or y-axis is a horizontal, so you're going to go from this side to this side or vice versa. Again, x-intercepts are changed, they're negated, y-intercepts not changed. Reflection across the x-axis, which is a vertical reflection, x-intercepts don't change, but the y-intercepts are negated. So let's look at some examples. Identify the x and y intercepts of f of x. Without graphing g of x, identify its x and y intercepts. So here's f of x, 2x minus 4, and we have a transformation, a horizontal. So this is going to be a horizontal stretch of 2. So remember, this is 1 over b, so b is going to be 2. So that means our x int is going to change and our y is going to stay the same. Whoops. We need to find the intercepts of the original. So this is a linear function, y equals mx plus b. So we probably recognize -4 is going to be our y-intercept. Or you can think of it, your y-intercept is when x is 0, your x-intercept is when y is 0. So to find our x-intercept, we're going to set our y or f of x equal to 0, like we did here. And then here's our equation, and then solve for x. And we're going to get an x-intercept of -2. So our intercepts then are -2, 0. And that's our x int. Our y int is going to be 0, -4. So the horizontal stretch changes this one only, and it's going to multiply by 2. So what we're going to do to get our new ones, we're just going to, let me get a different color here. So our new ones is going to be -2 times 2, 0, which is going to be -4, 0. I've actually done the colors opposite of the way they actually graphed them. So their blue is the original and their red is the change, but you know what I mean. And our y stays the same. So y int is just going to be 0, -4. Okay. Next example. Whoops, I went the wrong way. Identify the x and y intercepts of f of x without graphing, and without graphing, identify the x and y intercepts of g of x. All right, so this is a quadratic, and our transformation is here, which is a horizontal reflection, which means we're going to negate our x-intercepts. So what's our y-intercept? If you remembered standard form ax squared plus bx plus c, you'll remember that c is our y-intercept. So our y-intercept is going to be -1 or 0, -1. How do we find our x-intercept? Well, we set the equation equal to 0. So 0 equals x squared minus 1. And if you'll recognize this, we're basically just finding the zeros or the roots of this equation. Add 1. We're going to get 1 is equal to x squared. We're going to square root, and you're going to get x is equal to positive and -1. So we've got two x-intercepts, -1 and +1. Now, our transformation says that we negate those. So our new ones are going to be negate -1. We're going to get +1, 0, and negate this, and we're going to get -1, 0, and our y-int stays the same. And if you're very clever, you'll notice that we end up actually with exactly the same intercepts after we negate them. They just switched. Why is that? Because this is asymmetric about the y-axis, so when we do a horizontal reflection, you can't really tell it's been reflected. So even though we did transform them, the intercepts are all the same. All right, you should try and identify, well, first of all, find the x and y intercept of the original and identify the new intercepts for this transformation. All right, and here's another one that you should try. This is a quadratic, so here's the transformation. Find the x and y intercepts for this, and then figure out what the transformed ones would be. All right, now we're going to try and graph. So here's the function equation, f of x equals 1/3 x minus 2 squared, and the transformation is g of x equals 2f of x minus 3. So how are we going to do this? There's a lot going on here. Well, one way to do it is by using the intercept. So the original function, I mean, you can find the intercepts multiple ways. You can FOIL it, or you can set the y int. Whoops, sorry. If you set y, the y int is f of 0, so it's going to be 1/3 times -4. Oh, sorry, negative 2 squared, which is going to be 4/3. So that's your original y-intercept. Your x-intercept, you're going to set f of x equal to 0, whoops, and then solve for x equals 1/3 x minus 2 squared. Multiply both sides by 3. And you're going to get x minus 2 squared equals 0. Square root both sides. And you're going to get x minus 2 is equal to 0. Finally, x equals 2. So our original intercepts are 0, 4/3, and 2, 0. So what do we have going on? Well, we have here a vertical stretch of 2. Vertical stretches don't change our x-intercept. We're going to multiply our y-intercept by 2. So that gives us a new y-intercept of 8/3. And now we have a vertical translation down 3. Well, if we're going to move down 3, pretty much everything moves down 3. So both the x and the y-intercept are going to be changed by a negative 3. So this kind of shows you what's happening with the y-intercept. Started out here, we vertically reflected it, and this is the shifted point. I don't know, I think this is probably more confusing than it's helpful, but we're going to basically subtract 3. So 3 is basically 9/3, a negative 9/3 plus 8/3, which ends up being a negative 1/3. So this is our new y-intercept. What's our new x-intercept? Well, we're simply shifting 2 down 3, so it's going to end up being negative 3, 0. And again, once you have your vertex and one other point, we can find the symmetric value. So we're going to have 0 and a negative 1/3. Negative 3, and this is at a negative 1/3. So if we go 2 over, this would also be negative 1/3, and we could draw our curve.